Assalamu alaikum. Today we are here with another video, that is how to detect outlier in a data set. For this I have a data set of 5 variables where the operational self-sufficiency is my dependent variable and rest of 4 variables are my independent variable. To detect the outliers, we need to go to this data and import the file first. And how to import the file? For this you need to go to File, go to Imports, select Excel spreadsheet, browse where you have saved your worksheet, select it and select import first row as variable names because the variables were in my first row. Click OK. Okay, there are several methods to detect the outliers. We'll do it one by one, and in this video we'll only detect the outliers, right? So firstly we need to generate the ID against each row. For this the command is gen id is equals to _n. Press enter, go to datasheet, and you will see that id has been generated against each row for all the data set. Okay, let's start with detecting the outlier. The first method to detect the outlier is sorting. Here I am only taking the operational self-sufficiency to detect the outliers. With different methods you can detect the outliers of all the variables of your choice. Let's start with detecting it with the first method, that is sorting. For this you need to write sort and select your desired variable. Here the operational self-sufficiency is my desired variable. Click enter. Then go to the data sheet and you will see that the data of operational self-sufficiency have been sorted into ascending order, where the -0.09 is very lowest from 0.51, that is the second value in our data points. That means this could be an outlier in our data. Let's move on to the later data points, where 2.44 is also very far from 0.2.0017. You can see that the ID numbers has also been changed because we have sorted this data, right? So we cannot surely say that these are the outliers. For this we need to identify or check the outliers with other method. The second method to check the outliers is the graph box plot. For this the command is graph box your desired variable, comma mark 1, comma m label, bracket id and then bracket close. Press enter and here a graph box will be generated. Here you can see a graph box have been generated where these data points against the id code have been generated, because I have mentioned the command with the id to generate the graph blocks with the id, right? So here 4 data points are seen as an outlier. Let's move on to another method, that is the graph histogram. For this the command is histogram your desired variable, comma frequency. Press enter and here the histogram will be generated. Here you can see that the data is not equally distributed, but the outlier detection cannot be easily justified or easily seen. Let's move on to another method to detect the outliers, that is the spike plot method. This is also a graphical representation. For this the command is spike plot and your desired variable. Press enter and here spike plot will be generated. You can see that these data points are very far from the main data points. That means these data points are the spikes and outliers in the data which needs to be removed, which will shown in the later video. Let's move on to another method, which is the AV plots. AV plot method represents the relationship between the dependent and independent variable in a graphical representation form, but firstly we need to process the model of the data, that is regression. Dependent variable is operational self-sufficiency and rest 4 are my independent variables. Press enter. Then you need to mention the command of AV plots, and here you can see that the relationship among the dependent and independent variables are shown in a graphical representation where the data points can be seen a little scattered. You can see that debt to equity ratio in this relationship, these data points are very far from this main data set. That means these are the outliers in the data sets. Let's move on to another method, that is graphic metrics. Graphic metrics provide the graphical representation of all the variables, and for this the command is graph metrics, and then select all your variables. Here the complete graphical representation can be seen, where the scatteredness of the data can also be visualized in this graph. But as you can see that if we have more variable, then this scatter plot will be very smaller. For this we have another command, that is a half graph matrix plot. For this you need to select the same command, press comma, then type half, then it's enter. You can see that now half graph matrix have been made. Let's move on to another method, that is extremes. For this you need to install the extreme command, that is ssc install extremes. It is very important to write the same spellings, because Stata will not recognize if you make mistakes and any other issue. So try to use the same commands. Press enter. The extreme command is already installed in my laptop, but you can use it if you haven't. And the command for extreme is extremes and your desired variable. Extremes and then your desired variable, press enter, and here you can see that these 5 are the upper extreme values, and these 5 are the lower extreme values in the data set. Lower means the lower side of the data, and this is the upper side of the data, right? And you can also squeeze this or shrinken this with the interquartile extreme command, which is another method, that is interquartile range till 150% and 300%. Mostly researchers take these two data points if according to their data set. That means if the data points are above 150%, then those data points are outliers. Same is the case with 300. That means if the data points are 300% above, that means that data point is an outlier. I'll show you both methods so that you can make a comparison. Here the command is extremes operational self-sufficiency, comma, IQR, bracket 1.5, bracket close. 1.5 is 150% divided by 100 to make it into a numerical number. Press enter. And here you can see that these are the extreme values that are above 150%, right? Let's check with the 300%. And same command, but we'll change 1.5 with 3, that is 300 divided by 100. And here you can see that only one value, which is of the 55th observation, and the operational self-sufficiency value of 2.44 is an extreme value, which is greater than 300% data points of the complete data set. Another method is the z-score method, which is basically the standardized variable, generating the standardized variable and analyze that variable within the range of -3 to +3. For this you need to generate the variable. That for this the command is egen. OSS, I have renamed it as OSS. You can rename your variable as per your own choice. Then is equals to, then std, which is the standardization, then select your desired variable. Here a new variable has been generated, that is OSS. This is the standardized value of operational self-sufficiency. Here you can also see it in the data set as well. And how we can identify that this will check the outlier in the data set? For this you need to sort this variable. For this the command is sort, select OSS variable, press enter. Go to your data sheet, and here you can see that the OSS variable have been sorted out into ascending order. And now you need to analyze as that if the value is greater than -3, that is the, we can see, which is not the case in this part, the highest value is minus 2.975, which is lower than minus 3. And if we go to the upper side of the data, which you can see that 3.68 is the value which is above 3. That means checking it against the operational self-sufficiency, that means original data, you can see that 2.44 is the extreme and outlier in our data, because this value is greater than plus 3, right? So these are some of the outliers detection method through graphical representation and through different commands. But we can also analyze the outliers through tests. For this, you need to check out our next video. Till then, thank you and Allah Hafiz.